Welcome back to Pre-Algebra. I'm using Pre-Algebra for Christian Schools by Bob Jones University Press as my text. The topic that we're discussing today is simplifying algebraic expressions. In my text, it's section 2.5. You don't have to be using the same book as long as you're just following the same pieces of information. Before we get started though, I want to know, is it true that chicken soup is good for the soul? Is it good for your health? Well, yeah, of course it is, unless you happen to be a chicken. So, let's see what we're talking about here. I'm on page 52 in my text, and this says you can simplify an algebraic expression by rewriting it in a simpler equivalent expression. So, what exactly are we talking about here? Well, if we have 2 times the quantity 3n, we can use the associative property to come up with an expression that is more simple than this. Now, what's our associative property tell us? It tells us that the order in which you group addends or group factors, if you have a multiplication problem here, that the order in which you group factors can be changed around. So this actually, we could move these parentheses around. Right here this says 2 times the quantity, 3 times n. Well, let's move our parentheses and say, let's do this 2 times 3 first, and then times n. And you have a simpler form of this algebraic expression. 2 times the quantity 3n is really just 6n. So what we're going to be learning are some techniques that let us make our algebra a little bit more easy, more simple and basic to work with. So let's continue on here. I think I'll just leave my eraser hanging right down there. Let's look at example number 1, and this says simplify the quantity x plus 2 plus 9 by using the associative property of addition. So this is example 1, and they want to simplify x plus 2, closed quantity, plus 9. Once again, this is, since it's associative, even though it's not the multiplication, the property works for both multiplication and addition. And it says that the order in which you group, in this case addends together, doesn't change the value of your expression. So if we move these parentheses, so to speak, and instead of grouping together x plus 2, we group together 2 plus 9, then we can do a little bit more with this expression. Now we work inside the parentheses, and we have x plus 11. So this answer right here is considered to be a simpler form of this. And this is all that we're going to be working on. Now we have some vocabulary that we want to go ahead and introduce. We want to talk about coefficients. We want to talk about variables. We want to talk about terms and like terms. For example, 3x plus 2y minus 6. This is an algebraic expression. What makes it algebraic is the fact that you have letters in here. You have these variables. And it's an expression because there's no equal sign, there's no inequality sign. So it's just an expression. It has what we call 3 terms. It has a 3x, it has a positive 2y, and it has a negative 6. So what terms are? They are expressions that are joined together with either an addition sign or a multiplication sign. Here we have 3 times x, but that's only one term. You only get the term coming in when you're adding or subtracting them. This is an algebraic expression. The letter is called the variable, and the number in front of that variable, this is called the coefficient. And it is essential that you understand that the coefficient is a number that's bumped right up against the variable. This says 3 times x. 3 is the coefficient. X is the variable. And this expression right here has 3 separate terms in it. The first term, 3x, has a coefficient of 3. The variable is x. The second term, positive 2y, the coefficient is plus 2. You include the sign that's in front of it. The variable is y. Our third term is just the digit number 6. It's all right with terms. They don't all have to have the letters on them. Okay? Now we want to simplify an expression where we're using like terms. What do you think we're going to do if we have 7x plus 4x? Well, let's just think a little bit here. What if you had 3 balls plus 4 balls? How do you think you would simplify that? Well, yeah, exactly what you think. 3 balls and 4 balls, you have 7 balls. You added together the numbers, and you kept, as part of that description, what you had 7 of. You have 7 balls. Well, what they want you to do here is realize that you can use the distributive property here. I'm just going to write through it. If it makes sense to you, grab it. If it doesn't, don't worry. I'll show you how it actually works. 7x can be written as 7 times x, plus 4x can be written as 4 times x. What you have done is you have distributed this x over both the 4. This is x times 4, x times 7. So what you have is 7 plus 4 times x. X is distributed over the 7 plus 4. 7 plus 4 is 11x. 7x plus 4x is 11x. Just think about having what we call like terms. If the variable is the same, what you do is you add the exponents. Up here we had 3 balls and 4 balls. It's 7 balls. What if we had 3 balls and 4 bats? Can you combine those together? No, because balls and bats aren't the same thing. So if we have 3x plus 4y, can you combine those together? No, x's and y's are different, just like balls and bats are different. So this is what you do when you are doing what they call combining like terms. Let me make sure I don't knock this off. (3x plus 2x). We talked about those terms. We said that the number in front of the variable is called the coefficient. The letter is called the variable. We also need to know what we mean when we use the expression like terms. What like terms are, they have the exact same variable. Coefficients don't have to be the same. Somebody's got 2 balls, someone's got 10, someone has 1 ball. So the coefficients are different, but you're still talking about balls. So what terms do we have here that are like terms? we have 3x plus 6x plus 7y plus 3y. Well, it says the variables have to be alike. So 3x plus 6x, that's not an x, that's not an x. 3x plus 6x, what are we describing? We're describing x's. How many are there? We add the variables together. 3 plus 6 is 9x. What about this? 7y plus 3y. These are like terms. They have the same variable. What we do is we keep the variable and we add together their coefficients. 7y plus 3y is 10y. Now maybe you want to look at this and say, yeah, Miss Betsy, but I see something else going on here, and did you miss it? Anybody know what I'm talking about? Well, look at the first term and the last term that we have here. We have a 3x and we have a 3y. Shouldn't they be like terms? Because they both have a 3 in front of them. No. If you have 3 cats plus 3 dogs, can you combine them? No. In order for terms to be like terms, it has nothing to do with the coefficient. It has to do with the variable. And because the variable here is an x in the front, in the first term, and a y in the final term, they are not like terms. So let's go ahead and do a couple of examples that are actually from our homework. So I'm going to flip over now to page 54. Okay. Problem number 1. Simplify using the associative property of multiplication. 5 times 7b. Associative property means grouping can change. So this would be 5 times 7 times b. 35b. All there is to it. Very, very straightforward. This was number 1. Now let's look at number 10. This is a plus 34 plus 28. Not doing us any good the way we have it grouped together. You can change the grouping. 34 plus 28, a plus 62. Now you still don't know the value of this expression because you still have a variable. But it's easier to work with because you've at least combined the numerical portion of it. Okay, let me do another couple on this section. Let's look at number 20. This is number 20 on page 54, and here we have multiple terms that we're going to combine. This says 6w plus 8x minus 2w plus 3 plus 4x. Okay? 5 different terms here. W, x, and a number all by itself. Our commutative property tells us that we can flip-flop around the order in which we add numbers without changing the value of the result. So you could say, okay, I'm going to group together all of my terms that are the same, all of my like variables. So I would have 6w minus 2w plus 8x plus 4x plus 3. And you see what I did was I used little hash marks here to help me keep track of the fact that I was using every single one of the terms here. And I just organized them alphabetically. Now we have two pairs of like terms. The w's are like terms, the x's are like terms. What do you do now? You add their coefficients. Well, this doesn't say plus, this is 6 minus 2. It's the same as adding the opposite, 6 plus the opposite of 2. But 6 minus 2 is 4, and you keep the variable, which is w. Plus, now we have 8x and plus 4x. So we keep the variable, we add the coefficients. 8 plus 4 is 12x plus 3. And this is what they mean by simplifying an algebraic expression. Now let's look at section B. Section B says, simplify, then evaluate for these values of the variables. And they say A is equal to 3, B is equal to 4, C is equal to 2, X is equal to 6, Y is equal to 8, and Z is equal to 5. Okay? They're using 6 different variables throughout these problems. It's not likely that any of them use every single variable, but they're giving you the values for everything at the beginning. So let me pick a long one. Well, how about 28? This is number 28 on page 55. 8c plus 5y minus 2c plus 9y. When you do anything more than just a simple, tiny, basic little problem, it's always a good idea to go back and check your writing to make sure that you haven't made a transcription error. So let's see, this says 8c plus 5y minus 2c plus 9y. We have everything here correctly. Now let's go ahead and reorder our add-ins here so we have like terms together. We have c's and we have y's. 8c minus 2c plus 5y plus 9y. That made a mess, didn't it? Plus 9y. We have the c's together. We're going to combine the coefficients. 8 minus 2 is 6c plus 5y plus 9y. 5 plus 9 is 14y. This is a simplified expression, but is this all we're supposed to do? No, this says then evaluate for these values of the variables. So what do? Well, here, c is equal to 2, and y is equal to 8. So we substitute those values in. You have 6 times 2 plus 14 times 8, 12 plus 4 8s are 32, 12 plus 112 is 124. This is actually a 2-step problem. First it said simplify, then it said evaluate. So we combined like terms to get 6c plus 14y, and then we evaluated using c is equal to 2 and y is equal to 8, substituted those values in for the two variables c and y, and came up with a value, which is 124. So that's the end of our lecture for today, evaluating algebraic expressions. Thanks, and I'll see you next time.